I totally forgot to record. Oops. All right. Let's recap real quick. All right. My fault. I forgot to hit the button. All right. Statistics is a study of how to collect, organize, analyze, and interpret numerical information from data. Statistics is both the science and uncertainty and the technology of extracting information from data. Individuals are the people or objects included in the study, and a variable is a characteristic of the individual to be measured or observed. All right. Just for the recording, since I forgot to hit it, right? Let's come up with another example. What's something that you guys would like to study? You guys try. Or what's something you would like to know? Come up with something that you would like to know. Like ask. Yeah. hmm It could be anything. It don't have to be, it could be something fun.
Like, let's say, I guess if you want to open a business, you have to know, like, let's say, in my case, I would like to do a daycare, right? So in order for me to know that, I would have to know the amount of children that go to the school around the area, right?
Okay. Okay.
The age group
Okay.
that's gonna be going to the daycare, right? That way I
Okay.
can gather information, know how many children, when I do open a daycare, I'll be able to
hmm
accommodate how much food, how many
That's
people.
true. That's going a little bit more deeper than that. But yeah, that's true. That's all true. So mhm.
Start with that student.
True, true,
What
true.
is that?
Yeah. hmm
Certain information, I won't be able to know.
True, true. So,
Like, I live in an area that there's not that many children,
hmm
young children that, it's, well, you know, if most,
true.
they teenagers and stuff like that, so I want to.
So who would you say is the individuals in your study?
It will be smaller children, the age group.
Mhm. Families
Family,
with children, right?
yeah.
Okay. And then what characteristic are you studying about the children? It's their, you're interested in the kids, what?
Well, I would be interested with like more children with special needs.
Okay. Okay.
Or children, little children, small children, so that was our point. I guess it was
So
babies.
what makes a kid little versus a big kid? Like how do you know?
The age.
Age. So that's the variable,
Uh,
right?
would
So
be the age like 6 months.
however you want to do it. Right. Yeah. hmm So your study would be the families, right? And then the variable is the age of the children that the families have, all right? And if they don't have a child, they're not in your study, like that.
Well,
You know?
but
Mhm.
so
Mhm.
like how she's saying, right? Like she's in an area that not a lot of people have, like small children. However, even if she advertised,
She could do that, yeah.
But if there's not
Mhm.
children, then what I will do,
Mhm.
will target
Mhm.
the older teenagers. And then I will go for like after school program or something.
Okay.
In that age group, so that age group, I would say be like from 13 to 18. I would say 21.
Gotcha.
Right?
Okay. So that's going a little bit deeper. That's like next week's topic. But we're gonna get there. We're gonna get there, I promise. We're gonna get there. But yes, you can advertise, you can go out and get um children that from far away to go into the daycare and stuff like that. Especially if they have like a means of transportation to you. All right. All right. So let's continue. Let's continue. All right. This is all good stuff. All right. So the next thing I want to talk about is the variables. All right. So there's two kinds of variables that we have, right? We have something called quantitative variables and qualitative variables. All right. Let me give y'all the definition real quick. The shorthand of it is when you hear the word quants, Quant, quants, think numbers, right? Yeah, think of numbers, right? The other type of variable is called a qualitative variable, right? So look, here's a definition. So a quantitative variable has a value or numerical measurement for which operations such as addition or averaging make sense. A qualitative variable describes an individual by placing the individual into a category or group, such as male or female, right? So quantitative could be like the age for the children, right? You can add up all their ages and divide by two and all of that stuff. You could do math on their ages, right? But qualitative could be like let's say like my example where I was interested in the eye colors of the people that take Math 23, right? That's qualitative. Like I can't add brown eyes plus blue eyes, and divide by eight. That doesn't make sense, you know? So qualitative is like a general characteristic, right? Like it's like a word. Male, female, could be like eye color, hair color, those kinds of things, right? But quantitative variables, right? You can do an average of, you can add them together, you can do math on them, basically. That's the difference. All right. So these are the two types of variables. Then based off of those variables, you can do different kinds of analysis on them, right? Now, let's say that I collected some data, right? I collected some data and I want to know what kind of data do I have, right? So there's two types of data, right? So let me share that with you guys. You have something called population data and statistical data, right? Sample data. So here they are, right? In population data, the data are from every individual of interest. In sample data, the data are from only some of the individuals of interest. For example, right? Um, let's see. I'm trying to think of a really nice example here. Mm, all right. Let's say that I wanted to have an idea about how the people at BCC feel about the efforts to clean up the snow on campus, right? So the people that clean up the snow, did they do a good job or not? Right? Now, there's a lot of people here on campus. Like I can't go up to all like 8,000 of y'all and be like, yo, what you think? What you think? What you think? What you think? But I could go to a sample of the 8,000, like this classroom, right? And I can ask you guys, what do you all think about the efforts to clean up the snow on campus, right? Did they do a good job or not, right? You guys are a sample from the population of BCC, right? So you guys can be a representation of what BCC thinks, you know? I don't know if that is that clear? Does that make sense? Right? The population would be the whole campus, and you guys are a sample of that population. All right. So based off of that, I can make a generalization. I could say, you know what? Um, Based off of what this class says, I think BCC feels like this, you know? So that's it. Also, whenever I'm like analyzing data, I'm always always interested in the population parameters, right? But for many reasons, I can't always have access to the population. Sometimes the population is too great. Sometimes it's too expensive to get the population data. Sometimes it's impossible, you know? Like let's say that we take it up a notch. let's say I'm talking about politics and I want to know how does everybody feel in the United States about something, right? So United States is huge, like I can't possibly ask everybody what they think, but I could go to little cities, right? Like easy to access places, and I can ask them. I can take a whole bunch of samples, and then from those samples, I can make a inference as to what the parameters might be, right? What the population parameters might be. All right. Another important thing to know is that data from a population is fixed, right? Whereas the sample data is not fixed, right? Some samples will be a good representation of the population, and some will not. That's just the way of it, you know? So give an example, right? Like, let's say that, all right, I'm gonna just compare us to Fordham University, right? Let's say I ask everybody in this statistics class, right? What y'all think about Donald Trump and his administration, right? Versus, let me go to Fordham University and ask their statistics class, what do they think, right? Both sides might be biased in different ways, right? But each group's bias might not be a good representation of the whole United States, you know? So that's what I mean. So different samples, maybe they capture the population parameter, maybe they don't, but it's the best that I could do with what limited resources I have at the moment, you know? Right, right, right. Yeah. So like here's the idea, right? Let's say that I wanted to find the mean, the average of some characteristic of the data population, right? So like this sample would have its own mean, Fordham would have its own mean, right? But yeah, well, like let's say everybody in this class, right? Like let's say I was finding an average of like or dislike, just making it up, right? There's gonna be a mean here. There's gonna be a mean at Fordham, right? That doesn't mean that those means are capturing what the whole United States feels, you know? So like the samples could change, but the population, it is what it is. Like that ain't changing, you know?
So that whole population will be something you cannot change, the number or whatever.
Right.
What will change will be the sample,
The samples that you're getting, right?
but that will stay the same in the sample.
Right.
You said samples can change, but not population.
Samples might contain like a good representation of the population, but not all the time. Not all the time. So real quick, so from a population, right? You have what's called a parameter. So a parameter is a numerical measurement that describes an aspect of the population. From a sample, you have a statistic, right? And that is a numerical representation that describes an aspect of a sample, right? So it's really easy for me to come up with sample statistics, right? But in the grand scheme of things, I'm not really interested in sample statistics. I'm interested in population parameters, right? So that's the sauce right there. Mhm.
So let me ask you a question, right? So what we will always be looking for will be the population parameter, right?
That's what I want to know. But for many reasons, I can't always know that. Yeah. You're gonna see as we get deeper into it.
What is the sample be what we need to figure out to get the answer?
The sample is the answer. And then from that, I'll be able to make a educated guess as to what the population parameter would be. When we get into the examples, you'll see what I mean. All right. But if that's okay, I just want to jump to an example real quick. All right. So here's a story. The Hawaii Department of Tropical Agriculture is conducting a study of ready to harvest pineapples in an experimental field. So the pineapples, right? Those are the objects, the individuals of the study, right? If the researchers are interested in the individual weight of the pineapples in the field, right, then the variable is the weights, right? Each pineapple has a different weight, right? So at this point, it's important to specify units of measurement. All right. Got more to say on this. Basically, your first homework is you're going to hear some stories and you're just going to identify what's being studied and what's the variable. That simple. All right. So at this point, it is important to specify units of measurement and degrees of accuracy of measurement. The weights could be measured in the nearest ounce or gram. So weight is a quantitative variable because it is a numerical measurement. If the weights of all the ready to harvest pineapples in the field are included in the data, then we have what's called a population, right? The average weight of all ready to harvest pineapples in the field is a parameter, right? It's a description of the population, right? So suppose the researchers also wanted data on the taste of the pineapples, right? So a panel of tasters will rate the pineapples according to the category, right? Poor, acceptable, and good. Only some of the pineapples are included in the taste test. In this case, the variable is taste, and this is a qualitative or categorical variable, right? So each person is going to taste the pineapple and they're just going to rate it, like good, poor, or acceptable. All right. Notice that those are kind of like, I don't want to say feelings, so they're taste, right? They're not numbers. Right. That's what I want y'all to get out of that. So because only some of the pineapples in the field are included in the study, we have a sample. The proportion of pineapples in the sample with a taste rating of good is a statistic. All right. So how many pineapples scored good? That's a statistic. How you doing, man? Hmm. Sure. Go ahead.
Thank you.
The next thing I want to talk about is something called levels of measurement. All right.
Okay.
Levels of measurement. So basically, I'm kind of diving in a little bit deeper into the two types of variables, right? The quantitative variables and the qualitative variables. All right. So let me show you guys. You're welcome, by the way. We have two types of levels of measurement for qualitative variables, right? We have what's called nominal and ordinal, right? So nominal and ordinal levels of measurement, these are for qualitative variables, like the feelings, right? Good, adequate, not so good, for the pineapple tasting, etc., right? The nominal level of measurement applies to data that consists of names, labels, or categories. There are no implied criteria by which the data can be ordered from smallest to largest, right? For example, right? Let's say that I'm talking about the boroughs, right, in New York City, right? Bronx, Brooklyn, Manhattan, Queens, Harlem, right? So the boroughs, those are like different categories, right? It doesn't make sense if I say I put Manhattan before I put Queens, or I put like Staten Island before I put Manhattan. That like the order of them doesn't matter, right? That order doesn't matter, right? Um, Even though technically speaking, we know that Bronx is always number one, right? And all the other boroughs come after, right? But That's another thing. So that's a nominal level of measurement. The ordinal level of measurement applies to data that can be arranged in order. However, the difference between the data values either cannot be determined or are meaningless, right? So let's say that I have a store, right? And let's say in the store I sell, I don't know, like let's say I sell t-shirts, right? And then you know that every t-shirt has a different size. You have small, medium, large, etc., right? So for an ordinal level of measurement, right? I could put the t-shirts in order from smallest to largest, but it doesn't matter, right? If I put large before medium, right? It's it's meaningless, right? But it can be ordered from smallest to largest. That's ordinal. All right. And both of those are our qualitative variables. All right. So what about our quantitative variables, our numerical data variables, right? That's going to be our interval level of measurement and our ratio level of measurement. So for interval, right, the interval level of measurement applies to data that can be arranged in order, right? In addition, differences between the data values are meaningful, right? So I'll give an example of this, right? Let's say like the temperature outside, right? You can actually measure the temperature in an interval. It's between 5 degrees and 15 degrees outside. I'm just making it up. I don't know if that's true or not, right? But that's an interval level of measurement, right? For a ratio level of measurement, that applies to data that can be arranged in order. In addition, both the differences between the data values and the ratios of data values are meaningful, and data at the ratio level has a true zero. Pay attention to that mark right there. It has a true zero, all right? Right, like if I say I'm trying to think of something that has a true zero now. Like let's say that between not even shoe sizes. Let's say that you have like a sale. It's kind of a weird sale. Let's say that I'm following the price of something, right? The price of a plane ticket, right? Sometimes the price goes down, sometimes the price goes up, right? So that's kind of like a ratio, right? Like if it's going down by a couple of dollars, that would be like a negative value, right? If it's remaining constant, that's zero, right? If it's increasing in value, that means like some price is being added to it to push it up, right? Temperature is not a ratio, right? Temperature is an interval, right? And here's what I want you guys to think about when I say that. If I say that it's 0 degrees outside, right? That doesn't mean that there's no heat outside. It just means that the heat is really low that's outside, right? And when it comes to temperature, there is no true zero, right? There's just a time when there's less heat, and then there's a time when there's more heat, right? Just think of it like that, right? A true zero is like saying, hey, no problem. A true zero is like saying like there's nobody in the classroom next to us versus everybody's in here. Like that's a true zero, for example. Questions on this? Right. Mhm. Yeah, just think of that definition of true zero. That's for the ratio. Mhm. Correct. Yeah, correct. Yeah. Mhm. You guys will see this in your homework. Really, really easy. They give you a story, just identify what the variable is. All right. Mm-hmm. No, you'll see in the homework. It's not that bad. Like, for example, right? So let's say I want to identify the type of data. All right. I'm trying real hard here, y'all. Taos, Akuma, Zuni. I don't even want to try that saying that word. Are names of four Native American pueblos, right? From the population of names of all Native American pueblos in Arizona and New Mexico. Now tell me, what type of level of measurement do you think this is? Hold on. What to say? So we got four, right? We have nominal, ordinal, interval, ratio. Good, right? Because those are names of pueblos. I don't even know if I'm saying that right. Pueblos. All right, that's good. So that first one is nominal. Whoops. Sorry, I mean to make it that big. All right. In a high school graduating class of 319 students, Jim ranked 25th, June ranked 19th, Walter ranked 10th, and Julia ranked 4th, right? Where one is the highest rank. What is this? What level of measurement is this? Is it nominal, ordinal, interval, or ratio? These are the ranks in high school. Which one?
I don't know.
Mhm. Well, let's look at it real quick. First off, what kind of data is this? Is this quantitative data or qualitative data? The ranks. Which one? Mm, It's qualitative. Right? Here's the reason why, right? Yes, yes, I could add those numbers together, but those numbers are like names, right? Like the meaning between them is meaningless. Like the person who's ranked fifth is sitting here, and the person that's ranked 89th is sitting there. It means nothing. All right.
Oh,
But that being said, which one is it? Ordinal, right? I could put them in order, but it doesn't matter, you know? The rank is the rank. Mhm. All right.
How do you plan it for this?
Ordinal. Ordinal. Mhm. I accidentally gave out this answer earlier. Y'all probably all know it already, but let's do it anyway. So body temperatures in degrees Celsius of the trout in the Yellowstone River. What is that? What is it? Quantitative, good. So which one is it? Interval, good. How'd you know that? It has no true, right. That's why it's interval. It's temperature and it has no true zero. Right? All right, how about this? The length of the trout swimming in Yellowstone River. So how long the fish is. What would that be? Nominal, ordinal, interval, or ratio. Interval? Okay. Hmm. Give me something better than that. It is quantitative, so I'll give you that. It's ratio, right? So you can have a fish that has no length to it. It's zero, you know, in terms of like inches, the units, right? It'd be less than that. Okay. So literally, like that's your homework. Read the stories and then just identify what's what. You know? So I just want to recap real quick. Just recap a little bit. So procedure, how to determine the level of measurement. The levels of measurement listed from lowest to highest are nominal, ordinal, interval, and ratio. To determine the level of measurement of data, state the highest level that can be justified for the entire collection of data. Consider which calculations are suitable for the data. So here we go again. Level of measurement, nominal, right? A suitable calculation, we could put the data into categories. Ordinal, we can order the data from smallest to largest or worst to best, but each data value can be compared with another data value, right? It's meaningless in between them. Interval, we can order the data and also take the differences between the data values. At this level, it makes sense to compare the differences between the data values. For instance, we can say that one data value is 5 more than or 12 less than another data value, right? But there is no true zero, right? There's no true zero. Ratio, we can order the data, take differences, and also find the ratio of differences between the data values. For instance, it makes sense to say that one data value is twice as large as another. All right. That's your level of measurement. Now, let's talk about the two different kinds of statistics. All right. So I've been hinting at this a little bit earlier, but let's put a definition on what this is, right? So we have two types of statistics. We have what's called descriptive statistics, which involves methods of organizing, picturing, and summarizing information from samples or population. And then we have something called inferential statistics. All right. This involves methods of using information from a sample to draw conclusions regarding the population. All right. So let me give y'all the sauce real quick. Some people might care about this. I don't know. Some people might not. Let's talk about the test in the class, right? So the way that the class is kind of broken down, right? Test one is going to be about descriptive statistic. This is like chapters 2, 3, and 4, right? I give you a sample. You're going to give me back descriptions about the sample data that you received. That's test one, right? Test 2 and 3 is about inferential statistics, right? So yes, you guys have samples. Yes, you guys can get descriptions from those samples, but I'm interested in the population parameters, right? Like, what does the actual population mean? What is the actual population standard deviation? That's what I want to know, right? So, test 2 and 3 is going to talk about techniques on how we can guesstimate, right? Really estimate what the population parameters could be. That's what inferential statistics is. All right. Questions on this? You're good? All right. So now I'm telling you that you guys are going to get data and you're going to analyze it, right? But what are some of the different ways that we can get data, right? That's the next thing that we're going to talk about, all right? So we're going to talk about random samples. Again, I know we're going through a lot right now and I'm dropping a ton of vocabulary on y'all. It is being recorded, so you guys can rewatch it as you're doing your homework. All right. So if you don't get a chance to comprehend everything right now, just rewatch the recording, hear the definition, and then just knock out the homework. All right. Also, I don't know if I told y'all this, but you guys could use the formula sheet on your homework. All right. It's in the announcements. You guys can print it out and use it to help you with your homework. You know. So a simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample of size n from the population has an equal chance of being selected. Right? Most of the examples that we're going to deal with in this class, the samples are going to be like this, simple random samples. All right. I think this is like another homework assignment. All right, so in a simple random sample, not only does every sample of the specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply a simple random sample. Remember, for a simple random sample, every sample of the given size must also have an equal chance of being selected. All right. So here's some important features of a simple random sample. For a simple random sample, every sample of specified size n from the population has an equal chance of being selected. No researcher bias occurs in the items selected for the sample, and a random sample may not always reflect the diversity of the population. For instance, from a population of 10 cats and 10 dogs, a random sample of size 6 could consist of all cats. That's fair, right? So we have this population of cats and dogs, right? There's 10 cats and 10 dogs. Let's say they're running around in this room, right? And I want to take a sample of the animals in this room. It's fair that one of those samples could be all cats, right? Say the sample is of size 6, right? That is a sample. But as you know, this room has 10 dogs and 10 cats. So that sample is not a good representation of the room, but it is legitimately a sample from the population, you know? So that's it. All right. There are other techniques to getting a sample. So let's run through them real quick. So when you guys are running your experiments, not in this class, all right? These are like some ways that you can gather data for your experiments, right? So one sampling method is called a stratified sampling method, right? Groups or classes inside a population that share a common characteristic are called strata, plural for stratum. For example, in the population of all undergraduate students, some strata might be freshmen, sophomores, juniors, or seniors. Other strata might be men or women, in-state students or outer-state students, and so on, right? In the method of stratified sampling, the population is divided into at least two distinct strata. Then a simple random sample of a certain size is drawn from each stratum, and the information obtained is carefully adjusted or weighted in all resulting calculations. The groups or strata are often sampled in proportion to their actual percentages of occurrence in the overall population. However, other more sophisticated ways to determine the optimal sample size in each stratum may give the best result. In general, statistical analysis and tests based on data obtained from stratified samples are somewhat different from techniques discussed in an introductory class. For example, right? For your business, you want to have a daycare, right? Let's say that you only want to target students, excuse me, only want to target children from, let's say, 6 weeks old to like, I don't know, grade two. What's grade two? Like 10 or something like that, right? Let's say that that's the population that you want, right? That's your strata, right? That's what you're trying to target. Mhm. Okay. Another popular method of sampling is called systematic sampling, right? In this method, it is assumed that the elements of the population are arranged in some natural sequential order. Then we select a random starting point, and then we select every kth element of our sample. For example, people lining up to buy rock concert tickets are in order. To generate a systematic sample of these people and ask questions regarding topics such as age, smoking habits, income level, etc., we could include every fifth person in line. So the starting point is selected at random from the first five. All right.
So,
You make it up. You make it up, right? So like let's say, huh? Yeah, let's say that I gave everybody in here a number, right? From 1 to 30, right? It doesn't matter what your number is. And then like let's say I want to create a sample from all of you guys. And let's say that I'm gonna every third person, so like one, two, third person, then four, five, that's another third person, right? Every third person, I'm gonna collect data from them, right? Like let's say I'm gonna record their height. I'm just making it up, right? So like this is a systematic sampling, right? Now, am I gonna start at the third person? I don't have to. I could start at the 15th person and then every third person after that until I get my sample, right? So this is what's called systematic sampling, right? Everybody has a number. I'm starting somewhere random in that list, and then I'm gonna skip the same number each time to get my data, right? Let's see. What's another one? Let's talk about some negatives of this real quick before we continue. So the advantage of a systematic sample is that it's easy to get. However, there are dangers in using systematic samples. When the population is repetitive or cyclical in nature, systematic samples should not be used. For example, consider a fabric mill that produces dress material. Suppose the loom that produces the material makes a mistake every 17th yard, but we're only checking every 16th yard with an automated electric scanner. In this case, a random sample point may or may not result in a detection of the fabric flaws before the large amount of fabric is produced. Right? So there's drawbacks to it. You might be excluding an actual like error in your analysis, you know? A little bit off topic, but I'm gonna share with y'all, all right? So I like to watch Game of Thrones. I don't know if anybody's ever watched that before. All right. So they have this new spin-off show called A Night of the Seven Kingdoms, right? It's pretty dope, right? Anyway, right? I was actually hearing an analysis of the Targaryen families, right? They were saying that every third Targaryen is like batshit crazy, right? So like I just found that really interesting. Like this isn't that's an example of a systematic sampling, right? Every time they have kids, right? The third kid is like stupid, right? And then the rest of them is all right. Yeah. All right. Cluster sampling, right? So cluster sampling is a method that is extensive is used extensively, excuse me, by government agencies and certain private research organizations. In cluster sampling, we begin by dividing the demographic area into sections. Then we randomly select sections or clusters. So every member of the cluster is included in the sample. For example, in conducting a survey of school children in a large city, we could first randomly select 5 schools and then include all the children of each selected school, right? So this is what you would do to find your clients, right? But the government uses it on a bigger scale because they can't possibly hit up everybody, so they have to have some type of technique or way of getting to as many people as possible to make their understanding of how everybody feels. So that's the cluster. All right. And we got two more, two more, two more. All right. These for the advanced statistics users. Go ahead. Yeah, you could go. Yeah, no problem. So often, a population is very large or geographically spread out. In such cases, samples are constructed through a multi-stage sample design of several stages, with the final stage consisting of clusters. For instance, the government current population survey interviews about 60,000 households across the United States each month by means of a multi-stage sampling design. For the current population survey, the first stage consists of selecting samples of large geographic areas that do not cross state lines. These areas are further broken down into smaller blocks, which are stratified according to ethnic and other factors. Stratified samples of the blocks are then taken. Finally, housing units in each chosen block are broken into clusters of nearby housing units. A random sample of these clusters of housing units is selected, and each household in the final cluster is interviewed, right? Multi-stage, you putting everything together and you just making up your own sample right there. You know, that's what that is. Then you have convenience sampling. This is the one that happens a lot. So convenience sampling simply uses the results or data that are conveniently and readily obtained, right? In some cases, this may be all that is available, and in many cases, it is better than no information at all. However, convenience sampling does run the risk of being severely biased. For instance, consider a news person who wishes to get the opinions of the people about a proposed seat tax to be imposed on tickets to all sporting events. The revenues from the seat tax will then be used to support the local symphony. Excuse me. The news person stands in front of a concert hall and surveys the first 5 people exiting after a symphony performance who will cooperate. This method of choosing a sample will produce some opinions and perhaps some human interest stories, but it certainly has bias, right? Because you asking outside of a concert hall if they're down for the seat tax, it's going to support the concert that they just coming from, you know, right? So it is hoped that the city council will not use these opinions as a sole bias for a decision about a proposed tax. It is good advice to be very cautious indeed when the data comes from method of convenience sampling. All right. So those are different sampling techniques. That was a lot. Let's recap that real quick because that was a lot. Mhm. All right, so these are our sampling techniques right here. All right. So random sampling, right? You use a simple random sample from an entire population. Simple, right? Stratified sampling, divide the entire population to distinct subgroups called strata. The strata are based on a specific characteristics such as age, income, education level, and so on. All members of a stratum share the specific characteristic. Draw random samples from each stratum, right? Systematic sampling, number all the members of the population sequentially. Then from a starting point, random, selected at random, include every kth member of the population in the sample. All up to you, however you want to do that, right? Clustering sample. Divide the entire population into pre-existing segments or clusters. The clusters are often geographic, right? Make a random selection of clusters, include every member from each selected cluster in the sample, right? Multi-stage sampling, use a variety of sample methods to create successfully smaller groups of each stage. The final sample consists of clusters, right? That's just kind of putting it all together, right? Convenience sampling, create a sample by using data from population members that are readily available. That's it. All right. So we call the list of individuals from which a sample is actually selected the sampling frame. Ideally, the sampling frame is the entire population. However, from a practical perspective, not all members of a population may be accessible. For instance, using a telephone directory as the sampling frame for residual telephone contacts would not include unlisted numbers. So when the sample frame does not match a population, we have what is called undercoverage. In demographic studies, undercoverage could result if the homeless, fugitives from the law, and so forth are not included in the study, right? So, like, let's say that the government is trying to run a census, right? But you can't include everybody from the population because it's hard to reach them. As they were saying, maybe they're homeless, maybe they're fugitives from the law, etc. But they're still in the population, right? Under coverage. All right. And then last but not least, so in general, right? Even when the sampling frame and the population match, the sample is not a perfect representation of a population. Therefore, information drawn from a sample may not exactly match corresponding information from the population. To the extent that the sample information does not match the corresponding population information, we have an error called a sampling error. So a sampling error is the difference between the measurements from a sample and the corresponding measurements from a respective population. It is caused by the fact that the sample does not perfectly represent the population. A non-sampling error is a result of poor sample design, sloppy data collection, faulty measuring instruments, bias in the questionnaires, and so on, so forth, right? Sampling errors do not represent mistakes. They are simply the consequence of using samples instead of populations. However, be alert to non-sampling errors, which may sometimes occur inadvertently. All right. That's it for today. Any questions?
The homework is online.
Homework is online. You guys can start it right now. Take out your phones, your laptops. Did it? Awesome. Proud of you. All right.
We good? We good?
We good. We good. Just come up and sign the attendance before you leave. All right. Can I take this down or is anybody still copying? It's okay if you're still copying. Just tell me if it is. Turn it off.
I'm trying on the bottom.
It's not on the back either. All right, just write it on the bottom then. Oh, for what? Help you.
Oh, wait. Sorry.
Yeah.
Was I trying to log in last week? But it didn't work.
Let's try right now. You have your phone on you?
I don't see anyone here either.
It's not there?
Oh,
Appreciate it. Yeah, let's try right now.
Yeah.
Last call. Is this okay? I could take this down? Appreciate y'all. Thank you.